Hello and welcome to TCP and ICMP protocol analysis session. This is Gopi Venkatesan, a trainer and consultant having about 17 years of industry experience. In this session, we are going to understand the packet structure. Whenever a client is requesting some information from the server, how the packet is going to be constructed and how it is going to be treated by the intermediation device. This is what we are going to discuss today. So the agenda of this session is what? TCPIP analysis overview and ICMP protocol traffic analysis. Before getting into the packet capture, I would like to explain you the setup what we have to demonstrate. We have three PCs connected to the same switch and all three PCs are falling under the same IP segment. System A has an IP address of 10.0.0.10/8 and system B has an IP address of 10.0.0.20/8 and system C has an IP address of 10.0.0.30/8. Now, first of all, let's understand how the routing table is going to be built. The moment you assign an IP address to a PC, it automatically populates a table called a routing table. Now, let's see what is happening on Genesis 1. The IP address assigned to Genesis 1 is 192.168.1.101. Now, every IP address has two parts, network ID and host ID. Since 192.168.1.0 segment falls under class C, the first 24 bits meant for network ID and the last 8 bits meant for host ID. Hence, the PC can also be identified as 101 located in 192.168.1.0 network. Now, let's see the routing table of Genesis 1. To do that, I'm issuing a command called as route print. Okay, let's analyze the routing table of Genesis 1 PC. There's multiple columns. The first column says network destination, the second column is network, and third column is gateway, and fourth column is interface, and fifth column is metric. So the first column says to which are all the networks or to which are all the destinations Genesis 1 PC will be able to forward the traffic. Now, the first destination listed in the routing table is 127.0.0.0, which is nothing but my loopback network. So 127 with a subnet mask of 255.0.0.0, who can forward the packet or who is my gateway? Who is nothing but 127.0.0.1. The next entry in network destination is 192.168.1.0, which is nothing but Genesis 1's home network. Because Genesis 1 has an IP address in 192.168.1.0 network, he can forward the traffic to everybody in 192.168.1.0. So the destination is 192.168.1.0, the mask is 255.255.255.0. Who can forward the packet or who is my gateway is nothing but 192.168.1.101. So he himself will be able to forward the traffic. Now, the next entry in the routing table of Genesis 1 PC is 192.168.1.101. The above entry is the network entry, and this entry is nothing but the host entry. If I would like to forward the traffic to 192.168.1.101, and please observe the net mask portion is nothing but /32 bit or all 255. So when all 32 bits are matching on the network destination, what is that? 192.168.1.101. Who's my gateway? 127.0.0.1 means I'm just sending the traffic to my loopback interface itself. So the next entry in the routing table is 192.168.1.255. Again, it is also a host mask in there. So this network destination is known as a broadcast IP address. Whenever I say broadcast, the traffic is meant for everybody. Now again, the broadcast is also of two types, 192.168.1.255 and 255.255.255.255. Both of them are known as a broadcast, but 192.168.1.255 is known as directed broadcast, which means the traffic is meant for everybody in 192.168.1.0 segment, whereas all 255 is the traffic is meant for everybody in all the network which I can reach. Now, in other words, if the destination of the packet has an IP address of 192.168.1.255, then it will be forwarded to everybody in 192.168.1.0 network. Whereas if the destination of the IP packet has an IP address of 255.255.255.255, which is meant for everybody in all the network. On both the cases, who can forward the traffic? My gateway is 192.168.1.101. The multicast, if I would like to send a traffic to a group of people joined to a multicast group, who can forward the traffic? I myself can forward the traffic. So this is the routing table of Genesis 1 PC. Let's change the IP address in Genesis 1 PC and try to understand how the routing table is going to be modified. Now I'm changing the IP address to 10.0.0.10 and the subnet mask is 255.255. So I'm changing the IP address to 10.0.0.10 with a mask of 255.0.0.0. Now let's see what is happening. Okay, now the IP address of Genesis 1 got changed to 10.0.0.10 with a mask of 255.0.0.0. Now let's see the routing table of the same. Since Genesis 1 PC belongs to 10 network, now he will be able to forward the traffic to everybody in 10 network. See the network destination with a mask of 255.0.0.0, who can forward the traffic? 10.0.0.10. If he would like to forward the traffic to himself, like my 10.0.0.10, it can be forwarded to 127.0.0.1. If a broadcast needs to be sent, he himself can forward the traffic. If a flooded broadcast needs to be sent, he himself can forward the traffic. Now we understood that based on the IP address of the PC, the routing table is going to be built. Now I would like to show one more demonstration. This guy has an IP address of 10.0.0.10. Now I would like to assign a secondary IP address for him. Now getting into advanced, add an IP address. Let me call it as 192.168.1.101 with a mask of 255.255.255.0. Now let's see the routing table. Now Genesis 1 knows two networks. One is 10.0.0.0. The other one is 192.168.1.0. Let's confirm that by seeing the routing table of it. See here. Now the network destination has 10.0.0.0 network with a mask of 255.0.0.0. The gateway is 10.0.0.10. At the same time, he also knows about 192.168.1.0 with a mask of 255.255.255.0, who can forward the traffic 192.168.1.101. Let's remove it. Remove the secondary IP address. And you can observe that the entry is going to be removed from the routing table of Genesis 1 PC. Since Genesis 1 PC has only one IP address, now he will be able to forward the traffic only to that particular destination. So 10 network is the home network. Now apart from that, we will also be able to add routes in a routing table of Genesis 1 PC. Let's see how to add a route. Now let me say route add, let me think that 20.0.0.0 with a mask of 255.0.0.0. My destination is going to be 10.0.0.1. Let me assume like this. Okay, now I have made an entry to the routing table stating what? To the destination, means if Genesis 1 would like to forward the traffic to 20 network with a mask of 255.0.0.0, the next hop address or the gateway is going to be 10.0.0.1. Now let's see that in the routing table. Now we have made a static routing entry. Now, if Genesis 1 PC would like to transmit the data to 20 network with a mask of 255.0.0.0, the gateway address is going to be 10.0.0.1. In turn, 10.1 can be reached via 10.0.0.10. Now, let me give one more example over here. Route add 20.0.0.10 with a mask of 255.255.255.255, and the gateway is going to be 10.0.0.2. Let's see the routing table now. Now we have two entries added statically stating what? 20.0.0.0 with a mask of 255.0.0.0, gateway is 10.1, and if the destination IP address is 20.0.0.10 with a mask of all 255, the gateway is going to be 10.0.0.2. Now let's try to understand something. Now if I'm going to say ping 20.0.0.10, what I'm trying to mean is I'm trying to send some packet to a host called 0.0.10 located in 20.0.0.0 network. Now which entry is going to be matched? I have two entries, 20/8 and 20.0.0.10/32. Now since 20.0.0.10 20.0.0 network has two entries in the routing table, I'll try to match the longest prefix first. If the longest prefix matches first, then the gateway address will be used. If the longest prefix is not matching, then I'll be looking for the next longest prefix. Now in this case, we have /8 and /32 mask. Now /32 is matching or not? Yes, 20.0.0.10 with a prefix of 255.255.255.255 mask is matching, and the packet will be forwarded to 10.0.0.2. Now if I change the destination IP address to 20.0.0.11, then the longest prefix is here 20.0.0.10/32 is not matching, so the next available longest prefix only is 20.0.0/8. So the gateway is going to be now 10.0.0.1. Okay. Now we have Genesis 1 with an IP address of 10.0.0.10. We have one PC ready. Just to avoid the confusions, let's have our desktop changed to system A. Okay, now we have system A with an IP address of 10.0.0.10. Let's go and check the other PCs. Now we have PC called Genesis 2. Let us check it out, the IP address of it. Okay, we have 192.160.1.102. Let me change the IP address to I have changed the IP address to 10.0.0.20. Now I would like to keep this machine name as system B. Okay, check the routing table of the PC. B, now he knows about 10 network. Fine, we are set. We also have PC C or system C as an IP address 10.0.0.10. So 10.0.0.30 is the IP address. Right. Now we have three systems: system A with an IP address of 10.0.0.10, system B with an IP address of 10.0.0.20, and system C with an IP address of 10.0.0.30. We are perfect. Now let's see. Now from system A, I'm just going to check the connectivity with system C as well as with system B. So prior to that, let me explain you what all the setup we have. Okay, now I'll list it out. I have system A with an IP address of 10.0.0.10, system B with an IP address of 10.0.0.20, system C with an IP address of 10.0.0.30. Let me increase the font size so that you'll be able to clearly see it. Okay, fine. Now I have system A 10.0.0.10, system B 10.0.0.20, and system C 10.0.0.30. Let me check the ARP table of system A. There is no entries in the ARP table. Now let's also record the MAC addresses of each and every PC. MAC address of system A is 000C29F92AD7. Then system B MAC address is 000C29028996D. System C's MAC address is 001F3CA047D3. This is the MAC address of all three machines. Now from system A, I'm just going to ping 10.0.0.20. I'm just getting the response. Now let's see the ARP table. Now I have an entry found. 10.0.0.20 is the internet address, and the corresponding MAC address is 000C29028996B. Got populated. Let's see, check it out. The 00 is here. System B's MAC address is 000C29028996B. It's matching. Now the ARP table entry got means I have now there is a match found in the ARP table entry. Now let me remove this ARP entry D10.0.0.20. I have removed it. Now let's check it out. -A, no entries found. Now before I ping, now again I'm trying to ping 10.0.0.20. Before I ping, I would like to start the packet capture. I'm using a tool called Wireshark. I'm just going to start the capture. Select the interface on which the capture needs to be done. I'm just going to start the capture. While the capture is on, let me ping. Now we got the response. Packets are also captured. Let me go and stop the capture now. I'm interested in only the ping packets. Let me go here. Is what the packet I'm interested in. Okay. Is the ICMP packet, echo request and echo reply. Now let's try to understand what would have been done. Let's try to understand how this ping application is going to work. The moment I say ping, sample packets are going to be constructed. So let's see what is that sample packet. I'm just going to call the sample packet as "Are you there?" If somebody receives this packet, they will be responding back, "Yes, I'm here," right? But whom it is going to be sent, that becomes the question. Since ping application acting at layer 3, the first header going to be constructed by the application is layer 3 header information. Now what information is going to be filled, or what is going to be filled inside the layer 3 header? To IP address and from IP address. That's what is going to happen. Do I know the source IP address? Yes, source is 10.0.0.10. And how about destination? Yes, destination is 10.0.0.20. That means this application is trying to forward the packet to a host located in 10 network. Now I need to check is 10 network is reachable for me or not. Let us go and check the routing table of 10.0.0.10. Now 10.0.0.10 knows how to communicate to the entire 10 network. Now to reach 10 network, who can forward the packet? 10.0.0.10 itself can forward the packet. Now layer 3 header has been constructed. Let's move on to the next header. What is that? Once the layer 3 header has been constructed, now the next header what is going to be done is created is layer 2 header, in other words data link layer header. Now what information is going to be filled? Source MAC address and destination MAC address. What is the source MAC address? We know that the source MAC address is 10.10's MAC address 00 0C29F92A D7. Now I have filled source MAC address. How about the destination MAC address? Do I know the destination MAC address? No, I don't know the destination MAC address. So what I'm going to do here is I'm just going to pass this process. No, because I'm not aware of the MAC address of 10.0.0.20, another packet is going to be constructed. What is that packet called as? Let me save this file. And then let me open up a new file. To get the MAC address of known IP address, another packet is going to be constructed. And what is that application, or which application is going to construct this packet is ARP. In other words, we can also call it as address resolution protocol. And this is the application acting at layer 2 of OSI layer. So the first layer which will be constructed by the application is data link layer header. Now let's see the payload. What will be there inside the PDU. Okay. Now source IP, who is sending 10.0.0.10? What is the MAC address of sender? We know that already. To whom it is meant for? Destination IP 10.0.0.20, and destination MAC is all zeros, or else we can call it as 12 zeros. 0 0 0 0 1 2 3 4 5 6 12 zeros are going to be placed, and this is going to be the content. Once the ARP PDU has been constructed, now it will be handed over to the OSI layer for constructing the other layer headers. Now the first header going to be constructed by the ARP protocol is layer 2 header. What information will be filled in layer 2 header? As we know that it is nothing but source MAC address and destination MAC address. What is the source MAC address? Do we know the source MAC address? Yes, we know the source MAC address. Do we know the source MAC address? Yes, we know the source MAC address, nothing but 10.10 MAC address. And what is the destination MAC address? To whom it is going to be sent? See, the ARP packet itself is to get the MAC address from a known IP address. So what I'm going to do is, I'm just going to send it as layer 2 broadcast. Means at layer 2 level, it is going to be a broadcast. When I say broadcast, the packet is meant for everybody. Once the layer 2 header has been constructed, I'll be able to construct the layer 1 header also. There won't be any problem. Based on the medium type, it is going to be constructed. Once this packet has been constructed, and it is going to be kept on the wire. Now, the moment switch receives this ARP request packet, it boosts the signal, and it will be sending out on all of the available active port except the ingress port. Now, system A and system B both will be receiving it. Now, system A is sending this ARP request, which will be sent on through this port. Switch receives that packet, and it will be boosting the signal, and it will be forwarded throughout on all of the active ports because it is a layer 2 broadcast. Now 10.20 as well as 10.30, both of them will be receiving the packet. Now let's see from system C's perspective. Now 10.0.0.30 is receiving a packet. It can easily open the layer 1 header because based on the physical characteristics, it can be understandable for system C. Once the physical layer header has been removed, it sees that the layer 2 says it is meant for everybody. So I'm also part of the network, I'm just receiving the packet, so I'll be able to open layer 2 header also. Once the layer 2 header is opened, he's seeing that payload. Inside the payload, what is the question asked? If somebody is having an IP address of 10.0.0.20, please replace all zeros with the MAC address of 10.0.0.20 and reply me back. Since system C has an IP address of 10.0.0.30, he will be keeping silence. Whereas when the same packet is received by system B, he knows that the packet is meant for him, because layer 1 header has been removed and layer 2 header says the packet is meant for everybody. Once the layer 2 header has been removed, he comes to know somebody is asking the MAC address of 10.0.0.20. So I have the IP address of 10.0.0.20. Now I'll be responding back to 10.0.0.10 with my MAC address. What we call it as ARP reply. Let's try to understand the same. So the ARP request. Let's try to understand ARP response. Now this is what is going to happen. Sorry. Now sender IP is 10.0.0.20. Sender MAC is 10.20's MAC address. What is that 10.20's MAC address? Nothing but 000C29028996D. This is the guy who is responding. The sender's receiver IP is 10.0.0.10. Destination means the receiver MAC addresses. Do we know the MAC address of the destination now? Yes, of course. 10.10 with source MAC address of so and so have requested for the MAC address of 10.20. Now replying back to him. 10.20 is replying back to him. So there won't be any problem in knowing the MAC address of 10.10. It's already there. 10.10 MAC address is going to be filled. Now the ARP reply packet has been constructed. Immediately layer 2 header is going to be constructed. And what will be there in layer 2 header? We know that it's nothing but source MAC address and destination MAC address. What is the source MAC address? We already seen this one. Source MAC. Who is sending this? System B is sending the MAC address of so and so. To whom it is being sent? Destination MAC. .0.0. Who is sending? 10.10 is sending to 10.20. Now the next packet or next header what is going to be constructed by 10.0.0.20 is nothing but physical layer header. Based on the physical medium type it is going to be constructed. So what we understood here, ARP request is the layer 2 broadcast, whereas ARP response or ARP reply is the layer 2 unicast packet. Now we got the MAC address of 10.0.0.20. Let's open up. Now we got the MAC address of 10.0.0.20. Now we will be able to resume this process. Destination MAC address is what? Destination MAC address is since we have received the ASK response, now we know the MAC address of 10.0.0.20. Now we got the MAC address of 10.0.0.20. So I'll be able to construct layer 2 header. Once the layer 2 header can be constructed, the next header what will be done or what is going to be constructed is the physical layer header based on the physical medium on which the data is going to be transmitted, which will be constructed. Now ARP request has been constructed. Now once the physical layer is done, physical layer header is done, this data is going to be sent out on wire. Now ping request or echo request has been constructed by system A, which will be sent through this wire. Now switch receives this data on one of its port. Now switch is going to send the data only out on an interface which is connecting to 10.0.0.20 because switches are intelligent. Now he knows that the MAC address, destination MAC address is reachable only on this port, so the data will be sent out only on that port. A ping request or echo request has been forwarded to 10.0.0.20. The next packet constructed by 10.0.0.20. Hello, 10.0.0.10, I am here. This is the packet. When somebody asks me whether you are live or not, now what I'm going to say him, yes, 10.0.0.10, I'm live. Now once this content has been constructed, the next thing is going to be like layer 3 header, because ping application acting at layer 3. So the first header is layer 3. Now to whom the data is going to be sent? Source IP is 10.0.0.20. And then destination IP 10.0.0.10. This is filled. Immediately layer 2 is going to be constructed. Layer 2 is going to be constructed. In layer 2, source and destination MAC addresses are going to be done. Do we know the source MAC address? Yes, I know the source MAC address. 10.20's MAC address is and then destination MAC address is going to be done. Destination MAC address is going to be filled. Do we know the 10.10's MAC address? Yes, we got the MAC address. We found the MAC address from the ARP table because already the communication happened. Once layer 2 header has been constructed, now I'm just moving on to layer 1. Layer 1 can be constructed based on the physical medium on which the data is going to be sent. Once the physical layer has been constructed, it is sent through the wire by system B. Now system B have constructed his packet, echo reply packet, which is going to be sent through this interface, which receives the packet and sees the destination MAC address is reachable on this particular port, so it is going to be sent out only on this port. So because of this, echo request has been sent, and I'm also receiving echo reply on system A. I'm seeing reply messages. So I come to know 10.0.0.20 is live. Let us verify the same with the packet capture what we have done earlier. I'm just getting into the PC on which I have done the packet capture. See, even before the echo request, ping request has been forwarded, there are two packets have been captured. One is ARP, another one is also ARP. Now let's open up the ARP packet first. The first packet, I'm just opening it up. Okay, let me increase the packet size, the font size, so that you'll be able to see. Can you see that now better? Okay, fine. I think this is the maximum I'll be able to zoom in. Fine. The first packet what I'm just going to open up is the ARP. See, as we said earlier, ARP is a packet acting at layer 2, and this is the address resolution protocol request. In other words, the protocol data unit or the payload which has been constructed by the ARP application. And immediately the first header what has been constructed is layer 2 header. Layer 1 header is not visible for us. Now let's see what is the content of the ARP protocol. I'm just opening up the ARP packet. The hardware type is Ethernet, protocol is IP. Now I'm interested in this part. Sender IP is 10.0.0.10 and sender MAC address is what? F92AD7. In other words, 000C29F92AD7. That is the MAC address of the sender. receiver IP address, the target IP address is what? 10.0.0.20. And what is the MAC address of the receiver? We are not sure. We are just constructing this packet to get the MAC address of a known IP address. Once this payload has been constructed, the ARP protocol's payload has been constructed, it has been handed over to transmit to it is handed over to the application to transmit the data over the cable. Now immediately a layer 2 header has been constructed because ARP protocol acting at layer 2. In layer 2, what information is going to be filled? The source and destination MAC address. Who is sending this packet? 000C29F928D7 is nothing but system A is sending packet. To whom it is meant for? To everybody, to whomever is receiving this packet can open layer 2 header information. Now ARP request has been forwarded. Now let's open up the next ARP packet. What is that? ARP response. Now it's an address resolution protocol reply. Let's see what is the content. Now sender IP address is 10.0.0.20. Sender MAC address is 000C29028996B. To whom it is sent? 10.0.0.10. And what is the destination MAC address? 000C29F928D7. The ARP reply packet. Once the ARP reply has been constructed by 10.0.0.20, layer 2 header is what is going to be constructed. And the source MAC address is 000C29028996B. See here, it is the ARP reply is layer 2 unicast, whereas ARP request is a layer 2 broadcast. See here, destination is a broadcast. Now once we have received the MAC address of 10.0.0.20, echo request is being constructed. We had the discussion that ICMP protocol, ping is an application, makes use of a protocol ICMP, Internet Control Message Protocol, which is acting at layer 3. So because of that, the first header what will be constructed on top of ICMP PDU is layer 3 header. Now let's try to understand what is there inside the ICMP protocol, the payload. Now this is the data. I'm just entering the type is 8. Code is 0, is meant for echo request. ICMP messages are identified by type number and code number. Type number 8, code number 0 is echo request. Type number 0 and code number 0 is what we call it as echo reply. That we'll see later. Now what is this echo request? It's going to be constructed. Once the echo request has been constructed, header is going to be layer 3 header is going to be filled up. What is the source MAC address? Who is sending this packet? Source MAC address is 10.0.0.10 and destination MAC address is 10.0.0.20, and it's an IPv4 packet. Once layer 3 header has been filled, layer 2 header is also going to be filled. Source MAC address and destination MAC address. Echo request has been constructed. It is sent on the wire. If somebody is there with 10.0.0.20 is replying back with echo reply. Let's see the echo reply. The type number 0 and code number 0 is what? Echo reply. Once echo reply sample packet has been constructed, layer 3 header is going to be filled up. What is the source MAC address? Source IP address 10.0.0.20 and the destination IP address is 10.0.0.10. Once this is done, layer 2 header is going to be constructed. Layer 2 MAC address of source is 000C29028996B and this is the destination MAC address of it. So we have seen successful echo request and echo reply. Now we had the discussion about how the packet is going to be constructed from system A to system B when you are pinging. Let's review what we had a discussion. The moment an IP address is sent to a device, it automatically populates a table called what? A routing table. A routing lookup will help the device to identify the exit interface and the next hop address. We have seen this one. There are two types of entries, local and remote. What we have seen as of now is a local network entry. Now additional entries can be statically added by the administrator, that also I have shown you the demo, and default route can be useful when accessing the internet. This I will be explaining later. Now how do we verify the connectivity? Ping is an application used to verify the connectivity between the devices. Ping uses ICMP protocol. Ping is an application acts at network layer, hence the first layer conducted by the device will be the network layer header. ICMP messages are identified type number and code number. We have seen two types of messages, echo request which is type 8 and code 0, and echo reply is type 0 and code 0. So we are through with this first case study. The next one what we are going to have the discussion is case study number 2. Here we have two PCs, both of them belongs to different network, and we have the connectivity using a router.